Alright, in this video we're going to go over your Chapter 5 test review. Now, I know it's 30 questions long. I'm picking one of each type, and I'm going over one of each type. So, number 1, write negative 2x squared parentheses negative 5x squared plus 4x cubed in standard form. So, the first thing we're going to have to do here is distribute the negative 2x squared through the parentheses. So negative 2x squared times negative 5x squared, negative 2 times negative 5 is a positive 10, and x squared times x squared is x to the fourth. Now if you look, letter B is the only one that has a positive 10x to the fourth. So we could stop there, circle B, and move on. But say this was a positive 10x to the fourth, we would have to figure out the leading coefficient. So you just simply multiply the negative 2x squared times the positive 4x cubed. So negative 2 times negative 4 is negative 8. X squared times x cubed is x to the fifth. Because when you multiply like that, you add the exponents together. So the answer is negative 8x to the fifth plus 10x to the fourth. Now, when you first multiply this together, you get this term first. The reason I wrote it last, though, is because the question says in standard form. So since we needed it in standard form, your exponents need to decrease. So I put the fourth last and the x to the fifth first. All right, and then your answer is, of course, B. All right. This is number 3. It says, consider the leading term of each polynomial function. What is the end behavior of the graph? So the end behavior of the graph, it all goes down to your degree and your leading coefficient. Okay, so if your degree is even and your leading coefficient is positive, your end-tail behavior is up, up. If your leading coefficient is negative, your end-tail behavior is down, down. Okay, if your degree is odd and your leading coefficient is positive, your end-tail behavior is down, up. If your leading coefficient is negative, it is up, down. So let's come up here. We have an odd degree, so we know we're over here. We have a negative leading coefficient. So odd negative, it is up, down. So the answer is C. Since n is odd and a is negative, the end behavior is up and down. Okay. Number 4. It says write the polynomial in factored form. So we need to write the polynomial in factored form. So we have 6x cubed minus 60x squared plus 144x. Now, since these numbers are really large and we have a coefficient here, let's try to factor out the largest factor that we can factor out. So, looks like we can pull a 6 out of everything, and we can also pull an x out of everything. Okay, so 6x divided by 6x cubed is 6x squared. 6x divided by negative 60x squared is going to be a negative 10x. And then when you pull it out of here, you're going to get a positive 24. So now, to complete the factored form, we have to factor this. The 6x you just bring down. We're done with the 6x, but you have to keep up with it. You can't lose it. So now we just have to factor this. So since there's no coefficient here other than 1, we know this is x and x. This is positive, we know the signs are the same. This is negative, we know they're both negative. So what multiplies to 24 and then turns around and adds to 10? Well, you have 1 and 24, that's not 10. You have 2 and 12, but that won't add to 10. Then you have, 3 and 8, that won't add to 10. Then you have 6 and 4. Well, 6 and 4 add to 10. So there's your final factored form. And again, these two numbers here have to multiply to give you the 24 and add to give you the negative 10. All right, so that's all there is to factoring. All right, next one we're going to do is number 6. It says, graph the function and describe its end behavior. Well, from looking at the function, it's an odd degree, and our leading coefficient is going to be positive. So with an odd degree and a positive leading coefficient, we know we're going to be down, up. Okay, so the left side of the graph is going to go down, the right side is going to go up. So this one's out, and this one's out. So we've narrowed it down to B and C from the beginning. All right, so now let's figure this out. Well, this -3 means this graph moves down 3 units. Okay, means this graph moves down 3 units. Well, if you look at the normal x cubed graph, it looks like this. It comes up, goes through the origin, I missed the origin, and continues on up. So this little, I don't know what you'd call it, the little wavy part in here normally goes through the origin. All right. So that's what you want to look for to find out which one of these two has been moved down 3. Well, this part should normally go through here. Well, it looks like it's been moved up 3. This part normally goes through the origin, and it looks like it's been moved down 3. And in fact, it has. So the answer for this one is C. So that's the easiest way to do it. Think back to the parent function, or think back to what the non-transformed function should look like. And the non-transformed one for this, or the parent function for this one, is x cubed. So you have y equals x cubed. So this is what your y equals x cubed looks like. And of course, this one's been moved down 3. We don't really need to worry about the stretch because both of these have been stretched. And you can tell that they're the same shape, they're just in a different spot. So we just had to find out what spot they were in. Another way to verify it, this moved to the left 2 units, and 1, 2, this one is also moved to the left 2 units. All right, so that's another way you can verify it. All right, number 7, it says, what is a quartic polynomial function in standard form with zeros -2, 4, 4, and 3? Well, to take your zeros and turn them into factors, you're going to do x minus each one of these numbers. So we're going to have x minus -2, which is x plus 2. We're going to have x minus 4, and x minus 3. Now, what I would do, because this is a special case, this is essentially x minus 4 squared. And of course, when you have a minus b squared, it comes out to a squared minus 2ab plus b squared. All right, so x in this case is a, and b in this case is 4. So all we have to do is follow this pattern, and we're going to have these two middle ones right here multiplied through, and then we can work on the outside too. So if a is x and b is 4, that means a squared is x squared. AB will be 4x, 2ab will be 8x, and it has to be a negative, so negative 8x, and then plus b squared, well, 4 squared is 16. Now we can work on these two. All right, if you fold it together, you get x times x, which is x squared. You get 2 times x, which is 2x, negative 3 times x, which is negative 3x. Negative 3x plus 2x is negative x, and then 2 times negative 3 is negative 6. All right, so this is the beginnings of our polynomial. Now we just have to multiply all 3 of these by all 3 of these. And this is where the time's going to have to be spent. So x squared times x squared is x to the 4th. X squared times negative x is negative x cubed. X squared times negative 6 is negative 6x squared. Negative 8x times x squared is negative 8x cubed. That times that is positive 8x squared. And that times that is a positive 6 times 8 is 48x. And then this times this is a positive 16x squared. That times that is negative 16x. And this times this is a positive 96. All right. Now all you have to do is combine your like terms. So we have x to the 4th. So we're done with that. X cubes, well, we only have one more. We have negative 1 and negative 8, so that's negative 9x cubed. And then x squareds, well, we have negative 6 and a positive 16, so that gives us a positive 10. And then we have a positive 8, so that's plus 18x squared. So we're done with the x squareds. Then we have 48 minus 16. Well, that's going to be a plus, what is that, 32x, and then we only have one constant, so plus 96. All right, so that right there is your polynomial from your zeros. All right, that's your polynomial from your zeros. All you do to start with is you take your zeros right here. We have -2, 4, 4, and 3. You write them in the form of x minus that number. So x minus -2 is x plus 2, x minus 4, x minus 4, x minus 3. Then you just simply multiply everything together, and then you combine your like terms to get your final polynomial. All right, and yes, I did use a special case for this. Do you really have to? No. You could multiply the x plus 2 times the x minus 4 and get its polynomial. It's going to be different than this though. Then you could multiply these two, get its polynomial, and then multiply those together, and you will come out with the same answer. Okay? I chose to go the special case route because if you remember the special case, this is multiplying x minus 4 times x minus 4 is fairly quick. All right? So that's why I chose to do these first and then multiply the x plus 2 and the x minus 3 second. Okay? And whoops, that's actually a -96. Sorry about that. That's a -96. Because it's positive 16 and -6. So that's a -96. Sorry about that. All right, next one. This is number 8. The instructions for number 8 are: what are the zeros of the function and what are their multiplicities? So we have 4x cubed minus 12x squared minus 16x. Well, it looks like we can factor a 4 out of everything and an x out of everything. So if we factor a 4x out of here, we're left with x squared. Here we're left with -3x. And here we're left with -4. Okay, so now we can factor this. This will factor into x, looks like -4, and x plus 1. And of course we have the 4x here. Now to find the zeros, of course, we got to set this equal to 0. So 4x equals 0. So of course here x equals 0. Then we have x minus 4 equals 0. Add the 4. So x equals 4. And then x plus 1 equals 0. Subtract the 1. So x equals -1. So there's our 4 zeros. Since they only occur one time, and what I mean by that is you can only get the 0 one side of these, you can only get the 4 one side of these, you can only get the -1 one side of these. So therefore, they only occur one time, so they have a multiplicity of 1. So it looks like the answer is C. -1 for 0, and the multiplicity is 1. All right, number 11. The instructions for number 11 say, what are the real or imaginary solutions of each polynomial equation? So our polynomial equation is x to the 4th minus 40x squared plus 144. Now, even though the exponent here is a 4, and here it's a 2, and here it's nothing, it still follows the same pattern as x squared minus 40x plus 144. Okay, it follows the same pattern. So we can still factor this. All right, we're just going to have to factor it again. After we factor it into each one of these parentheses, we're going to have to factor each one of these parentheses again. Okay, so what times what is x to the 4th? Well, that's x squared. Okay, since this is positive, we know both signs are the same. This is negative, we both know both signs are negative. So now we have to figure out what multiplies to 144 and adds to 40. All right, so you can play around with factors of 44. We know 12 and 12 is 144, but that doesn't give us 40. We know 36 and 4 times 4 is 144, and 36 plus 4 is 40. So it's going to be 36 and 4. Because, like I said with the previous one, 36 times 4 is 144. 36 plus 4 is 40. And we already figured out the signs, so we know the signs are right because this positive here means both signs are the same. This negative here means they're both negative. All right, so now we have to factor both of these. Well, both of these are just the third case on the special case chart. It's a squared minus b squared. Well, what times what is 36? Well, the answer is 6. So this is just x minus 6 and x plus 6. Same thing here. What times what is 4? Well, that's 2 times 2. So it's going to be x minus 2 and x plus 2. All right. Now you just have to set each one of these equal to 0, solve for x. When you do, you'll find out that the answer is A, positive and negative 6 and positive and negative 2. All right. So even though this isn't x squared minus 40x plus 144 like I wrote over here, you can still start to factor it the same exact way. The only difference is, since you do have an x to the fourth and an x squared, instead of just being x minus 36 and x minus 4, it's going to be x squared minus 36 and x squared minus 34, which then, of course, each one of those will factor again, and then you just set each one equal to 0 and solve for the x values. Okay? That's all there is to that one. All right, let's look at number 12. It says x cubed equals 216. All right, well, if we subtract the 216 from both sides, we get x squared minus 216 equals 0. Well, if you recognize that this is simply 6 cubed, we have the difference of cubes here. And remember, when you have the difference of cubes, it factors into a minus b times a squared plus ab plus ab plus b squared. Okay, so in this case, a over here, in this case, a is simply x because the cubed root of x cubed is just x, and b is simply the cubed root of 216, which is 6. Because the positive and negatives of the numbers will take care of themselves over here. All right, they'll take care of themselves over here. So we just have to fill in a and b now. So we know x minus 6, and then we know x squared plus 6x plus 36. All I did was fill in a and b with a as x and b as 6. Now you just set this equal to 0 and solve for x. So when you take x minus 6 and set it equal to 0, you're going to get x equals 6. Well, these say negative 6, these two say positive 6, so these two are ruled out immediately. So now, since this is not factorable, we're going to have to run it through the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So in this case, our a is now 1 because the coefficient on x squared is 1. Our b is 6 because it's plus bx, so b is 6. Then, of course, c is the constant, just 36. So now, again, we just simply plug in. We're going to have negative 6 plus or minus the square root of 6 squared minus 4. Since a is 1, I'm going to leave it out. And then, of course, all of this is divided by 2a. And, of course, a is 1, so I'm just going to leave it off. So we have negative 6 plus or minus the square root of 6 squared minus 4 times 36. Well, if we start to do the math, we're going to get negative 6 plus or minus the square root of 36 minus 144, which comes out, divided by 2. Now I'm going to have to move over here. So negative 6 plus or minus the square root of negative 108 divided by 2. Well, let's see what we can pull out of negative 108. Well, we can pull out a 36. 36 times 3 is 108. I found that on the first try. What you want to do is you want to start dividing 108 by perfect squares. When you find a perfect square that goes into it evenly, when I say evenly, I mean a whole number. So like in this case, 36 times 3 is 108. So since 6 went into it exactly 3 times, that means 108 is divisible by 36. So we have negative 6 plus or minus. Now, we know that we're going to have an I because we're taking the square root of a negative, so I'm going to go ahead and pull that out. And then we have 36 times 3 divided by 2. Well, the square root of 36 is 6. So we're going to have negative 6 plus or minus 6I square root of 3 over 2. Now, since the 6 and the 6 and the 2 are all divisible by 2, we can reduce it. Negative 3, 3I. So our final answer is negative 3 plus or minus 3I times the square root of 3. So let's find where that is up here. Well, since we've narrowed it down to C and D, it has to be letter D. All right. So you have to watch out for these because this is, like I said, it's just the difference of two cubes. And the difference of two cubes factors into a minus b, and then parentheses a squared plus ab plus b squared, where a is simply x because x cubed is a cubed, so a is just x, and then the 216 is b cubed, so you have to take the cube root of that to get 6. Then you just fill out your a's and b's up here, set them both equal to 0, solve for x. This one comes out easy because you just get x equals 6. This one you have to use the quadratic formula, which you should already have seen and know how to use. All right, so that's it for number 12. Next one we're going to is number 17, which says use synthetic division to find p of 2, p of negative 2, for p of x equals x to the 4th minus yada yada yada. You can read it. All right, all this means is this is the remainder theorem. You remember us going over the remainder theorem? Which means if you do synthetic division with your polynomial, whatever your remainder is your answer. That looks like 710. So we're going to do synthetic division. We're going to put the negative 2 out front. We're going to put all our coefficients. And whatever our remainder is what p of negative 2 equals. Okay? Whatever our remainder is what p of negative 2 equals. So remember, drop the 1, negative 2, negative 8, positive 16, 14, what is that, negative 28, so that's negative 21, and that is 42, so this is 52. So the answer is 52 because 52 is our remainder. All right, that's all you got to do for that. 52 is the remainder, so we are finished. All right, we are finished. So anytime you see use synthetic division to find p of a number for a polynomial, just whatever the number is in parentheses, put it out front, run your synthetic division. Whatever your remainder is your answer. All right. Next one we're going to do is number 21. It says, what does Descartes' rule of signs tell you about the polynomial? Well, if you remember with Descartes' rule of signs, you just count the number of sign flips, and that's it. So you write it as is, count the number of sign flips. Well, from there to there is 1, from there to there is 2, and from there to there is not a sign flip. So that means for positive zeros, we're going to have 2 or 0, because remember you got to take your number of zeros, take your number of sign flips that you have, and subtract 2 until you hit either 1 or 0. When you hit 1 or 0, you're finished. Now for the negative zeros, you go through and you find your odd-powered exponents, and you flip the signs. So that's going to be a positive 3x squared. That's going to stay a plus x squared. This is going to go to a positive x, and then the 6 is going to stay negative, because this is a 1. So this goes positive, that stays positive, that goes negative. Count the sign flips again, doesn't change, there's 1. So which means we have 1, negative 0. All right. So let's see, which one of these says that? There are either 2 or 0 positive zeros and 1 negative. So bam, the answer is D. Because remember, root or 0 means the same thing. Okay, root or 0 means the exact same thing. All right. All right, so let's keep going. Next one we're going to do is number 23. It says, find all the zeros of the equation. Well, the first thing we need to do is get that 100 over with the rest of the equation. So plus 4x to the 4th plus 24x cubed minus 96x squared plus 25x minus 100 equals 0. All right, so here's what I would do. Normally, we would start and we would do the rational root theorem to find all our possible rational roots. Well, with our constant being negative 100, that's going to be quite a lot of possible roots. So what I would do is I would look here, and it's either going to be a 4, a negative 5, or a positive 5. All right? Or it's going to have I and negative I. Okay? Well, what we can do right off the beginning is, since the imaginary roots always occur in pairs, we can mark them out right there because they only have a positive I. And they have to occur in conjugate pairs. So you have to have a positive and a negative. So we can rule these out from the beginning. So we know it's going to be one of these two. So let's try 4, because if 4 works, the answer is C. If 4 doesn't work, the answer is D. So let's put a 4 out front and run our synthetic division. So we have negative 1, 4, 24, negative 96, 25, and negative 100. So negative 1, so that is negative 4, so that's 0, so that's 0, so that's 24, so that's 96, so that's 0, so that's 0, it's 25, that's 100. So since our remainder is 0, that means 4 does in fact work, so our answer will have to be C. 4, negative 5, 5, I, and negative I. If 4 hadn't worked, it would have automatically have been D. Okay, and then the 5 or the negative 5 would have just been a double root. Okay, so for ones like this, when you see the imaginary roots, if you don't have a positive imaginary root and the same negative imaginary root, like I and negative I, or say 2I and negative 2I, or say 3I and negative 3I, all right, you have to have the same root, both positive and negative. So here we have I and negative I, or you could have a coefficient in front of them, but they have to be the same thing, just one positive and one negative. Since we didn't have that in A and B, we knew we could rule that out immediately. Then we tried the only thing different between these two, which was the 4. Okay, since we tried the only thing different, which was the 4, plug the 4 in, run your synthetic division. We got a 0, which means 4 is a root, which means the answer has to be C. Because if you did 5 and negative 5, you would also get a 0 as well. All right, so that's how I would do 23. Kind of a little shortcut way to do it, but hey, the answer is multiple choice, so that's what I would do. I wouldn't take the time to do it any other way. All right. So this video is about 30 minutes long now. I've got 2 more I want to do with you. I want to do 25 and 29. But since they're both going to take a while apiece, what I'm going to do is I'm going to save those 2 for part 2 of this video, and that will be recorded this afternoon, and it will be posted this afternoon. All right. So go ahead and make sure you understand how to do these. I think I did 11 problems here. Make sure you know how to do these 11 problems, and if you can do these 11 problems, you should be able to do up through number 23 on the exam. Just with these 11 problems, you should be able to do up through number 23 on the exam. All right, and then when I do 25 and 29, that should allow you to be able to do the rest of them. All right, so make sure you can watch this as many times as you need to. Make sure when you're done, you can do 1 through 23. All right.